This work is about human-swarm interaction based on hand gestures. Gestures are recognized by the robot swarm through distributed sensing and consensus. The main motivation of this work is to develop an intuitive modality for interaction between humans and a swarm of robots. We aim to exploit mobility and multi-hop communication for cooperative gesture sensing and to design distributed consensus strategies. Each robot is equipped with a support vector machine for hand gesture image classification. The classifier is trained using a 70,000 image dataset acquired from a swarm deployed at a large number of different viewpoints. This setting allows us to gather a large amount of images corresponding to different robot positions. Different viewpoints lead to different classification accuracies. Images which are hard to classify because of a bad viewpoint usually result in classification vectors with a large entropy value. That is, the probability values for the different classes are more or less uniform. In this example scenario, the swarm searches for a hand wearing a red glove. When a robot detects the glove in its view, a message is broadcast locally and relayed throughout the robot network in a multi-hop fashion. In response, the other swarm robots move to observation positions which optimize the discriminative capabilities of the swarm. When a robot's beacon blinks, this indicates that it has sampled and classified the image as one of a possible set of gestures. Its opinion is propagated into the swarm and opinions are accumulated until a decision is made. Each robot considers all received opinions. When the confidence on a particular hand gesture class exceeds a given threshold, the robot takes a decision, which is propagated to the swarm. The color of the LED ring around each robot represents its confidence. The value of the confidence threshold determines a trade-off between a decision accuracy and speed. In this example, accuracy is given precedence over speed. Robots communicate locally through a low-bandwidth, line-of-sight, infrared-based system. Opinions and decision message packets are forwarded in a multi-hop fashion. The next sequence shows the entire decision process in detail. After an image is acquired by a robot, the glove is detected and segmented. Features are computed on the resulting mask. The robot classifier returns a classification vector. The opinion is propagated to the swarm. In a similar way, the swarm continues to generate and propagate new opinions which may be conflicting. All available opinions are incrementally taken into account by each robot and statistically processed. When a class stands out with high statistical confidence, the robot issues a decision, which is communicated to the rest of the swarm. The system is robust to occlusions and failures. Robots which are unable to see the hand do not contribute to opinions, but participate in message relaying and consensus building. Hand gestures can encode any predefined set of commands. The gestures displayed so far encode furniture-like structures that are interpreted and built by a swarm of Roombot robots. We also train the system to recognize finger counts, which can encode different commands. For instance, a finger count of 2 might mean that the swarm should split into 2 groups moving in opposite directions.